Good afternoon, everybody, or good morning, depending on your location. My name is Ashley Fortune, and I'm coming to you from the U.S. Fish and Wildlife Services National Conservation Training Center in Shepherdstown, West Virginia. I'd like to welcome you to the mini-webinar series that's held in partnership with the USGS. This series is part of the Landscape Conservation Cooperatives and Partners Project Outreach Strategy. All right, let's get started. Sean, welcome.
Thank you, Ashley, and thanks everyone for joining us today. Welcome to the Landscape Conservation Cooperative Integrated Data Management Network Series, Integrated Data Management, or IDMN, that you'll hear us mention several times during the call. The IDMN project was funded by the National LCC Network Office and contained or was participated by over 20 organizational partners over the course of the last 3 years, including 9 LCCs. Those organizations were represented by 50 or more investigators, and as I said, the project has been 2 years in the making. The IDMN project looked at ways to bring coherence to a rather fractionated information management landscape. Specifically, the project tried to address ways LCC partners dealt with the basic building blocks of data management, building and sharing science products with partners, securely storing those data for the long term, and evaluating ways to get those outputs to collaborators and cooperators, and eventually to the public. Over the course of the 2, maybe almost 3 years that the IDMN has been working on this, the project scope was expanded to address ways to track projects that sponsored these scientific outputs, as well as build communication products and tools to help community members work better together. These efforts always kept other landscape-level efforts in mind, especially the National Climate Change and Wildlife Science Center and the network of climate science centers across the nation. The IDMN project assembled 6 teams of information management, natural resource, and communication specialists to evaluate and test different approaches. From this effort, the teams defined ways different LCCs and other landscape-level projects could not just coexist, but constructively work together. The IDMN project is winding down, but the work is not. We all recognize that quality information management and technical transfer and science delivery is an ongoing effort, and that the technology is quickly changing. We hope that this team and other partners will continue to contribute and to collaborate on integration pathways for the LCC and other collaboration projects. These integration pathways should focus on data sharing options and fostering data integration partnerships, including data sharing, facilitating use of new integration options, collaboration on guidance documents, and fostering hardware and software solutions partnerships, software solution partnerships among LCCs and the climate science centers. To get these integration pathways started, the IDMN project generated a variety of products. These include metadata and data standards to help groups work together in specific domains, tools that let projects take advantage of partner capabilities, and collaboration concepts. As we start to wrap up the IDMN project and begin to deliver the products as were promised in the original proposal and developed over the course of the project, we decided to hold a webinar series this summer, and today is the 4th installment of this webinar series. It focuses on the IDMN Toolshed, and presentations following this introduction will be given by Brendan Ward of the Conservation Biology Institute, Dell Long of the U.S. Geological Survey, and Ed Laurent from Connecting Conservation. Please take advantage of the following 2 webinars, which will be held on August 14th and August 28th, where we begin to start talking about project tracking and then talk about the IDMN as a complete package and what it means for the next generation of data integration challenges. Today, specifically, we'll be talking about the IDMN Toolshed. The project developed several integration points between ScienceBase and Data Basin, a catalog and framework for evaluating tools for the LCC network, and through that plan and do process, develop best practices for developing tools to support integration. So I'd like to welcome Brendan Ward, Dell Long, and Ed Laurent to talk about the IDM Toolshed.
Hi, this is Brendan Ward with the Conservation Biology Institute, a nonprofit with about 30 staff who provide scientific and technical expertise to support the conservation and recovery of biological diversity. The IDMN Toolshed is composed of members from several organizations, both within the government as well as outside. Each of us represented tools, map and data viewers, or platforms, and brought our collective experience to the table. This is truly an integrated team effort, and we learned a lot from each other as we worked through this project. Today, I will be presenting an overview of what we've been working on and wrapping up for the IDMN Toolshed and how we'd like to see this grow into the future. I'll go over some of our team objectives and deliverables. We will share a few high-level lessons learned from our collective represented tools and platforms. We'll briefly discuss the ScienceBase and Data Basin integration pilot. We'll share a few best practices for data management and tools. And at the end, we'll demonstrate how Griffin Groups is going to be used to grow this effort into the future. Before we really get into it, we need to define some of our terms. The term tool covers a lot of territory, and I'll reuse it throughout to cover a fairly broad definition. To break it down into some specifics, there's analysis and processing tools, which basically, as we defined it, take data in and spit data and hopefully information back out. There's map and data viewers, which allow users to interactively explore data visually through the context of a spatial data viewer and a map, or through other data viewers that present charts and tables. As well as platforms, which bring together tools and viewers and combine those with a catalog of resources to give users a really full-featured application. So into our objectives for the Toolshed. When we got started at the end of 2012, we defined several objectives that we would work on over the course of this project. We realized very quickly that it would not be possible for us single-handedly to create an open source toolshed of tools that would meet the wide variety of needs of the LCCs, in large part because we only represented a small number of tools and platforms, and it was inappropriate for us to try and take over other people's tools to host them within a centralized framework. Instead, we chose to focus on tasks that we hope will provide the foundation for growing this toolshed idea into the future and see wider adoption of the existing tools, as well as better development and coordinated development of tools by the LCCs into the future. Some of our specifics were to start developing a catalog of existing tools, as well as the framework for evaluating those, capture lessons learned from our various represented platforms, integrate Data Basin and ScienceBase, and identify some best practices. We are handing those off in the IDMN's Roadmap to Interoperability document. We have put the integration between ScienceBase and Data Basin into practice. It's already been used by several LCCs and other users. And we've created a group in Griffin Groups for participation around these deliverables to see them grow into the future beyond the end of this specific project. So jumping into some of our lessons learned, one of the things that we found across all of our tools and platforms was that we were all challenged by trying to meet the needs of our broad audiences. In particular, communicating about data is difficult. It's hard to communicate the nuances and technical details of data representation, different ways the data are structured. It's hard to communicate the different capabilities that those bring along within a particular system. And we found a strong lack of good visual icons that we can use to represent some of these key concepts. We've also found that we were challenged by providing workflows for such a broad range of users and trying to cover the spectrum of providing enough simplicity so that the tools and platforms are accessible for non-specialists, while at the same time providing advanced features for power users. We also found that we were challenged, especially on the integration front, by standards. We found that common data and metadata standards and data structures have not been widely adopted, both within our represented platforms as well as those that we're trying to integrate with outside of this specific effort. We found that different ways of representing data really complicates the exchange of information between different systems. For instance, I may call something title and somebody else may call it name. Perhaps we mean the same thing, Perhaps we don't. We have to bring a lot more to the table to work out that negotiation for exchanging information. We also found that substantial effort is required to meet existing standards, but this didn't always result in a cleaner information exchange. Often, we have developed our own data structures that meet our specific needs, and the data standard doesn't allow us to carry along all of that information. So there's information loss along the way. We found that some standards, like Web Mapping Service, permit too much variability. They let people have too much flexibility in how they implement certain key aspects, like getting information about layers within a map. And this means that you have to handle many more cases when you're trying to integrate with those data sources and present them within a unified platform that allows the same capabilities for many different data sources. We also found within the team that we were challenged by some of the core technologies we were using did not actually expose data or metadata according to some of the standards, meaning that you had to publish it out in a way that wasn't directly alongside your map services. This makes it harder, for instance, to catalog thousands of map services originating from one location into a metadata catalog like ScienceBase. You have to follow an external process separate from the data to get those bits of information represented in, whereas we'd really prefer if the metadata and the data live very closely together. So moving into our integration effort with ScienceBase and Data Basin, we've covered this on every one of the preceding webinars. I'm going to try and give it a different focus here. But I want to remind you of some of the reasons why and who we were trying to reach with this. So why we went after this specific pilot was to specifically demonstrate power of integration of these platforms for meeting the needs for landscape scale conservation by providing an easy-to-use workflow and reduce the duplication of resources. The last thing that we want to see is users having to catalog and store their data in many different systems to meet their broad audience. We'd love it if they could put their data into one place and use it many places. Keeping with that, what we built amplifies the strengths of the existing platforms. ScienceBase brings strong cataloging and archival on federal IT systems to the table, and Data Basin brings feature-rich map viewer and collaboration tools to the table. Who were we trying to reach with this? Our immediate audience was LCC staff, LCC projects, and agency staff as a means for sharing deliverables coming out of LCC-funded projects and LCC data resources within their collective regions. We wanted to make a workflow that made the content discoverable on ScienceBase and allowed content curators to pull this into Data Basin and present it in compelling ways. And in so doing, this integrated approach allows us and the LCCs to reach a much broader audience. We developed several integration points to empower this workflow. The one that's been out the longest is allowing the import from ScienceBase into Data Basin, which brings along with it the authoritative metadata as represented in ScienceBase. And through this whole process, we've been aiming for similar functionality from data resources originating from ScienceBase as those that are represented natively inside of Data Basin. And in keeping with that, that means that we have open sourced one of our analytical tools and have been in the process for quite a long time now of trying to get this out into ScienceBase. And we're hoping by the end of the IDMN project that that's fully integrated. It's a great learning experience in how challenging it is to take a simple tool and share it between two fairly complex systems, especially when the core technology gets in the way nearly every step of the way. One of the more recent things we've added is to allow the harvesting of unique database and data sets into the ScienceBase catalog. So about this? Well, we started building on existing mapping standards using web mapping services and ArcGIS map services published by ScienceBase and consumed within our map viewer inside of Data Basin. Between both ScienceBase and Data Basin, we have roughly similar representations of information. We think about spatial resources in roughly the same way, which makes some information exchange relatively easy. And we used agreed upon conventions for sharing information. Specifically, in this case, we deliberately chose not to use an existing standard. Neither party had standardized around that. We both had our collective or respective data representations, and it would have been very inefficient and not effective with respect to budget to adopt a different standard for information exchange. Instead, we leveraged the existing APIs that we had already built to meet our own needs, and it was a simple matter of connecting the pipes up, and it has been working really well. We have been very happy working with the ScienceBase team to work through this process. Long term, both of us are looking toward adopting a broader range of standards that will allow us to better integrate with other platforms. Next, we're going to move into the best practices section of the talk. Dell is going to cover some best practices around data management, and I'll jump back in and cover some best practices around tools and some software development practices specific to developing tools. We're going to get into some of the weeds here, but our objective is to share some of the high-level concepts that we hope you will keep in the future as sideboards as you develop RFPs, evaluate proposals, conduct projects funded by the LCCs or agencies or other stakeholders. We're not necessarily trying to teach you software development here, but we want to give you some of the watchwords to keep in mind as those go forward. All of those are intended to help better support integration into the future. Dell, take it away.
All right, thanks, Brendan. This is Dell Long with the USGS, and let's start off talking a little bit about data management. Why is data management important? Good data management ensures that data are maintained in a manner that ensures legal and scientific defensibility, as well as providing it for future access. Some key points when we're thinking about data management, data should be a lasting resource, and data management helps ensure this. We want transparency and following provenance to let others see our plans and how we're managing things. It helps reduce redundancy and waste. If I can find a similar data set, then I don't need to produce it myself. I can just use the existing resources. Other things to think about are, data must have appropriate metadata and documentation to be usable and understandable. I need to meet scientific integrity requirements, as well as state and federal regulations and any other regulations in the research field. And finally, well-documented data that are easily accessed may be integrated more readily into existing project or other data, reducing redundant work and adding value. Management plans, as it says, they're not yet systematically adopted across the LCCs. DMPs are really more important than just a bureaucratic requirement. As Dwight D. Eisenhower said, plans are nothing, but planning is everything. They assist with visibility, reproducibility, and validity of research projects because the data are well documented, including approach and methodology. They help ensure that data and data products are accessible and available for the long term. And creating a data management plan is really consistent with best practices. It initiates the process of gathering metadata and documentation throughout the project lifecycle. And the planning process can help the researcher find issues with source, provenance, permanent storage of end products, et cetera, that they might not have thought about. Just going through the planning process can make you think about things that you wouldn't have thought about before. So while the plan isn't the most important, the planning process is. The thing that comes out of our data management plan is metadata for all the data that we're going to have. Metadata allows data to be understood and reused. Standard metadata makes it searchable in metadata catalogs like ScienceBase. And data really should be considered incomplete without a metadata record. In the future, somebody finds the data, and if we don't have a good metadata record, no matter what the format, that describes how to use it, what the parameters are, et cetera, it's really useless. Standard metadata formats, of course, are preferred because then we can use these tools that we're talking about in this talk to interact with them and do things that people might not have thought of before. So most scientific data has metadata in the form of a publication, but again, if we have FGDC, CSCGM, an ISO 19115 record, whatever, these tools that we're developing can pick those up and make them searchable and make them interacting between different platforms. So as Brendan pointed out, tools means a lot of things. We need to keep those tools in mind throughout the data management process, not just using tools for managing data, but managing data to allow the use of tools. I will turn it back over to Brendan for the next slide.
All right, thank you, Dell. Okay, so jumping into some good sideboards with respect to how you approach tools for the LCCs and other stakeholders. When you're trying to make your tools available or develop them as part of your projects, one of the first things that you really need to think through is who is your audience? What questions are they going to ask and find answers to within your tool? Are they focusing on specific geographies or specific themes? What level of technical complexity is appropriate? And as you work through these questions, there's, of course, a whole hierarchy of sub-questions underneath these, but these will help guide the nature of the tool that you're trying to build. When you're thinking about audience, think about how you're going to reach them, how you're going to connect with other tool developers or data consumers or tool users through the use of documentation, illustrating uses of your tool with use cases and examples, providing help materials, and very importantly, providing webinars to teach people how to use the tool and provide good examples for when and how they might go about using those. You know who you're trying to reach with your tool. You need to define your requirements. These have a huge impact on how successful your tool is going to be, as well as how much it's going to cost. So we recommend that you prioritize and sequence things into meaningful phases and don't just build wish lists. Don't go about the question of assessing all of your wants across all of your stakeholders. Find their needs, find their really critical needs, and try and find a way of sequencing that out so that you can actually deliver a successful result every step of the way, rather than trying to bite off too much all at once. Design something that will take years to build and do everything for everyone that they could ever want over time. That's the kiss of death, unless, of course, you've got access to unlimited resources. Be willing to revisit priorities along the way, but don't get caught in the endless circle of redefining your priorities every step of the way. There's times within this sequence where that's appropriate, and you want to make sure that you come back to those periodically and make sure that you are truly on track for meeting the needs of your stakeholders. And while you're at it, discuss your tool needs with other tool builders and technical experts. Figure out if you're being realistic. What we've seen from our own experience is something that seems very easy at face value is never that easy. And sometimes it's a whole lot less easy than you could ever anticipate from the outside. So we highly recommend that you reach out to other experts, technical experts or other tool builders that have done similar things, and just get their quick assessment of whether or not your tool is something that's tangible and achievable or covers too much territory. You know what you want, evaluate existing tools. What we found is that there's lots of resources to find tools, but they're not very well connected yet, and it requires a lot of knowing where to look. There are many domain-specific places to go looking for specific tools, but they're not yet pulled into a centralized catalog. It's not widely adopted yet for very specific tools, such as ArcGIS geoprocessing tools that you'd use within your desktop GIS environment for, water use planning. And this relies on tool creators and others cataloging their tools within a centralized system. And this is one of our core recommendations in the report is, as you build tools, catalog them so that they are discoverable by other people. This reduces redundancy. It also relies on users telling their success stories with tools. We find that people are more likely to pick up and use existing tools when they hear how great it is to meet other people's needs. If they hear nothing, it's harder to evaluate whether or not that tool truly could work for their needs. One of our observations is that building it yourself is usually more expensive in the long run, but gives you more flexibility. To which we'd want to challenge you to think through this question: do you really need that much functionality? You often might want that much functionality when you set about to design a tool, but are you willing to commit the much larger amount of resources required to build that? Or are existing resources used well on top of existing tools, may not meet your full wish list, but may get you 3/4 of the way, and that still gets you further along to success. So if you've evaluated existing tools and you haven't found one that meets your needs particularly well, and you've decided to build it yourself or build within your projects or so on, you need to ask yourself some key questions. Who's going to build the tool? Are they going to stick around after they've built it? This is particularly important for third-party contractors. Who's going to maintain this into the future? If this tool truly becomes successful, maintenance is critical. You want a stable platform on which to add additional functionality to better meet the needs of your stakeholders into the future. If the people that built your tool have come and gone, it becomes that much harder to carry this on into the future, unless you follow certain other best practices that we're going to hit in just a moment. And also, as you're building out a tool, who's going to review it? Having a small group from within your core stakeholders or your steering committee or whatever else who can review periodically according to those phases that we defined earlier and make sure that the tool is on track, showing success, and likely to be used for its intended application. Some key principles to keep in mind as you're building out tools: don't repeat yourself. There should be one and only one place within your code base representing the authoritative location of a piece of information or a chunk of processing. Don't repeat chunks of code that add 2 plus 2 in multiple places throughout your code. Do it once, and that way if you have a bug to fix, you've got only one place to go get it. Don't repeat others. Assess what else is out there for their ideas. Use available components to build a new tool wherever you can. Don't work alone. We have, within even our own team, seen a tremendous value from collaborating around ideas and going through formal and informal code reviews and functionality reviews. Often it's very helpful to see something from a slightly different perspective and can challenge you to go back and build the tool in a slightly different way that better meets the end. I also highly recommend that you follow Agile development practices, that you define a vision up front and just enough of the technical details to get rolling. Don't overplan. Don't try to come up with the specific technical plan over the next several years, because your priorities are going to change as you build this. You want to break it down into smaller incremental phases and evaluate your success with respect to your vision each step of the way. This gives you a much more flexibility to recommit your resources to move in a different direction if you find that your initial ideas are not panning out in the way that they need to best meet your needs and your stakeholders' needs. I recommend the use of style guides. This makes it easier to code together and maintain code into the future. This is the same way that style guides apply to writing scientific documents. They give structure, they give naming conventions, they give us all a common way of representing information so that we can all look at the same piece of code or same structure within a tool and easily pick up and get rolling with it. There's many resources available for specific applications and specific languages to help you get going. To treat code and tools as a product in and of themselves. If you're doing an exercise that involves developing source code, place value on that source code. Peer review it in the same way that you would peer review publications. And documentation is really, really, really important, both for sharing your code as you're building that tool out, as well as maintenance into the future, as well as integration with other tools by other users. Consider testing. Everything benefits from testing. Often when we're building small tools, we test them by hand. Once we've proved that they work, we move ahead. We're all pressed for time and don't have enough time to really hack away at tests here. But even specific tools benefit from tests. They help ensure the validity of our results and reproducibility of our results. You can't just assume that well-written code is going to produce good results. It's very easy for typos in code to, instead of adding 2 plus 2, it's 2 minus 2, and you get a completely different conclusion at the end. This helps protect you from your future self. If you've got tests in place, these are things that you can continue to test your code base against as you make new changes to your code. If everything still passes as before, great. If things start to break, those easily let you jump in and find the bugs and fix them before you roll this out to your users. There's lots of different testing frameworks out there to use. I also highly recommend you use not only version control for building tools, but distributed version control. So instead of keeping copies of your source code or your files around version 1, version 2, using names in the files to indicate what version it is, that doesn't scale. Instead, use distributed version control tools which allow you to, in part, centralize your code and in part make it very easy to share your code base with other people, while at the same time retaining authoritative control. This makes it easier to follow a review process. Other people can take a copy of your code base, make some changes to it, and then submit those changes to you through what's called a pull request that you then explicitly have to review before you check it into your code base. It provides an easy mechanism for peer review within the same tool. The tools for managing distributed version control are getting increasingly popular and easier to use. No longer are you relegated to using the command line and a whole long complex set of commands to be able to do checkout of code and update of code. There's many graphical user interfaces that provide this capability for you. And there's some awesome platforms for hosting code to use within distributed version control systems like GitHub and Bitbucket, which are both used within all of our tools that we're talking about here. So moving from there, one of our goals and recommendations from the Toolshed was to advance the use of open source. By something being open source, it reduces redundancy because you can find existing tools and use that for other applications. You can adapt someone else's code to meet your needs. So from a tool builder's perspective, why would you open source? One primary reason would be to build a community around your tool. But in order for this to succeed, that tool must be generally applicable and solve someone else's problem, and most likely many other people's problems, while not trying to solve too much problem space all at once. Focused is better. The community will usually only help improve the tool if they benefit from it too. If it's something that's very valuable to them, then they're going to they have a vested interest in seeing it improve. If it's something where they aren't deriving as much value from it, they're not going to contribute back. For this to succeed, documentation is really, really important. Often tools can be really awesome in terms of how they work, but if they lack documentation, they're not going to get picked up by the community. Nobody's going to know how to install it, run it, what it's even trying to achieve. So as you're working toward open sourcing something, documentation is one of the key elements you need. You need to build trust with your community. You don't want to break their applications and making willy-nilly code changes within your own code base. And like I said earlier, this helps ensure reusability. Another reason why you'd want to do open source is transparency. This promotes openness of your code base. You're not necessarily solving someone else's problem, but you're putting your code out there in case anybody else wants to go through it and find any potential issues with it. This is important for federal projects. I believe many federal projects are required to be open source from here on out. And this, like I said, may help people find bugs or security flaws, but keep in mind, people aren't going to go trolling through your code base to find bugs. Only those that really need to go looking for them will, as we've seen from several recent outbreaks and security-related bugs in core technologies used across the web. So with that, I'll hand it off to Dell for the slide.
Okay, thanks, Brandon. So for ScienceBase, the core catalog code is open source right now, as well as some Python client codes that we have out there for people to use to write their own applications against our catalog. As Brandon mentioned before, it's a system created by the federal government, so everything is technically public domain. We just don't have things exposed via Git like we do the core catalog because of passwords and configuration and things like that. But any piece that you wanted to get, we could cleanse the code and send it out. But so we're going to move eventually from our existing stash site to the USGS official GitHub site when our internal review process and documentation is complete. Like Brandon said several times, documentation is very important, and our documentation isn't quite up to par yet for a real open source project. As I mentioned before, other components are not yet open source, like our user directory, our authentication and authorization, the application that we use to maintain vocabularies and controlled values lists, the things that aren't really as interesting, I guess, to other people. But the core catalog code is available publicly right now.
So from the data basin perspective, our core is not open source. Why? Most of it is glue code. It's solving our problems, and it's not solving those of other groups. We feel very strongly that when we go to release something open source, we want to solve other people's problems. And so we're working more toward a model where the building blocks that we use within our system that we develop, we share back out, realizing that places a substantial burden on us to do all the documentation and work with building a community around those. We definitely support the concept of open source. It just hasn't made sense for the core. We've open sourced 3 things so far, all of them around tools on ArcGIS server, and we've got several more in the works around NetCDF map serving functionality, because we feel that this is something that's a core component to our system, and it's not necessarily well served yet by the existing tools already out there, but we want to make available what we're already working toward. We also collaborate and contribute back to several open source projects that we are gluing together within our core everywhere that we can. Thinking back a little bit about one of our main goals here with tools, it's not just to develop tools, it's to build tools that can be integrated. And so when you're looking at tools from an integration perspective, just like we were defining requirements and objectives around tools specifically, now we need to define core objectives in our audience for the integration. Why are we doing this integration work? Who are we trying to reach with it? What specifically are we going to do to achieve that? And how are we going to go about doing that? How are we going to maintain it in the future as each thing that we're integrating moves forward on its own path? So all valid questions to work through as you're putting something together for integration. To build tools to be reusable and integrated with elsewhere, you've really got to define what's called an application programming interface, or API, as a core component, and documentation of that is really important. This is what allows systems to talk to each other. For instance, in the ScienceBase and Data Basin pilot, we're using both of our APIs to connect to each other and share information. Where you can, use existing standards for transmitting and sharing data, metadata, and standardizing the nature of the API itself wherever appropriate. Okay, so moving back up a little bit more, some of our future goals, as the IDMN winds down, we want to see this effort grow. So we've created a group out in Griffin Groups to collaborate around the toolshed concept. And there's several companion groups out there that Ed's going to show in just a moment. In this one specifically, we have shared our existing catalog. We realize that it's far from comprehensive. We've only got I think it was around mid-20 odd number of tools in there, and there's many hundreds out there. But in setting this up, we're trying to define some of the characteristics that we'd like to collect around tools to make them easily discoverable within the LCC network. So as you can see here, we've got a series of pages where we're providing details about some of these tools. We also have a link within the description of the group itself to our full tool catalog spreadsheet that we developed as part of IDMN. And we've got some instructions defining how we'd like folks to participate in this moving into the future. And it's a two-pronged approach. We want you to come to Griffin Groups to describe and communicate and collaborate around tools. And we want you, as you're building out tools or finding useful tools, to catalog those into ScienceBase so that other people can find them into the future. Griffin Groups is also a great place to share and refine data and metadata standards and best practices, and centralize all of that information into one place. And so with that, I'd like to hand it off to Ed to give us more of an in-depth demo of Griffin Groups and how that could be used to support IDMN and other related efforts into the future.
Thank you, Brendan. So this is the toolshed on Griffin Groups. To find it, you can just go into the search box on the right side and start typing in toolshed, and you will see it rise to the top here, and then you click the button to go to the site, to the group. Once you're within the group, you can see the information that Brendan just described, and down on the bottom is a page tree where the pages that describe the different platforms, map and data viewers, and tools are provided, and there's also the evaluation template. If we go to the evaluation template, you can see that it provides some very short categories for describing different tools, and these are wikis. So you can, if you are a member of the group, you can click Edit and open up a viewer to be able to edit this page. And then down at the bottom, there is a place to comment on it. So in the case of Data Basin, Brendan has provided a description of Data Basin. This can be edited by anybody in the group, and it can also provide a place to have discussions about enhancement requests or bug reports outside of the tool itself. These are, if there is that process within the tool itself, it's probably better to use that one. But this provides a forum for other tools that may not have that capability. If a tool requires more than just a single dialogue, we can also create groups around the specific tools and for sharing different links and use cases, files, having discussions about those tools. That's what we did for these grid standards that were endorsed by US NABC. There is the tool design and evaluation group that can also complement the toolshed. This is a place where tool developers can go to have discussions about different thoughts about building tools or enhancements to tools or ways to evaluate the tools. And so that's another resource that is on this site. Some other groups that can complement the toolshed are groups like the Conservation Science Standards Group. This is mostly a list of bookmarks to different standards that are out there. For example, habitat classification systems, grid systems, and data schema. So this information from groups like the Conservation Science Standards Group and the Open Source Group, which is another group on Griffin Groups, could be used to help populate the toolshed. Other groups that are relevant include the Landscape Conservation Design Group, and then we can also set up RSS feeds like shown here, where information can be pulled from other websites that may be relevant to the toolshed and be able to display them on that group's profile. This is just a widget that can be moved around just through drag and drop by a group administrator, and has a very simple interface for setting it up. The toolshed could also be read as an RSS feed in other websites, like we have done for the Avian Knowledge Network. This is a news feed that is being read from Griffin Groups into this website. There's also a way to search for site members under Teams, Site Members, and you can do very complex searches using what we call the Core Conservation Competency System that was designed in collaboration with U.S. Fish and Wildlife Service, where you can have a series of checkboxes to find, for example, people who have expertise in data and information management and specific programming languages, and use an and search to find them even within a geographic radius from their zip code. There are a lot of other groups that could be relevant to the toolshed, and you can find them by clicking the Groups button, and then which shows you the list by most popular, which means the number of members, but you can also filter these and sort these groups in other ways. And all of Griffin Groups is built on the ELG social networking engine, which is open source. Almost all the code is available on GitHub as the core function of ELG, as well as many community-provided plugins. There is, like Data Basin, some of the core code for Griffin Groups is not available on ELG because it's very unique to Griffin Groups, but we can provide ways to be able to access a lot of that information. Much of it, the API reference is available through the developers link, and then the community link provides access to many of the plugins that are on Griffin Groups. So this is also an open source project. And I'll bring that back to Brendan.
Thank you, Ed. So with that, we're at the end. So thank you, Dell and Ed, for helping present this, and Sean for kicking us off. And thanks to all the Toolshed members for helping make this group possible.
So we do have a couple minutes for questions, if anybody has them.
Hey, Ed, it's BJ. I'm wondering if the sort of, I can't remember what you call it, but it looked like an experts database. Is that interacting in any way with the databases that are resident on the LCC websites, or is it just resident to Griffin Groups?
Unfortunately, each one of these sites has developed the expertise databases somewhat independently. And that's an issue that Griffin Groups we're working to help out with through Griffin Groups, trying to develop a standard for these different checkbox selections and interface that is sort of a simple Ajax-based interface, so that you can quickly dive down into pretty deep, very specific competencies. Unfortunately, there's going to be some crosswalking needed to link up all those different expertise systems.
Right. I could see that being pretty useful, to be able to crosswalk it or search from one place for the expertise levels. And I don't know if Griffin Groups is the place to do that. It seems like it might be. All right, thanks.
Thank you. Yes. Yeah. Hopefully, we can get these systems crosswalk together and make that happen.
Well, I want to thank everyone for joining us. Thank Brendan and Dell and Ed for their presentation, and also remind everyone that the next IDMN webinar will be August 14th, same time, which is noon Mountain Time. You can figure out what time that is for you. And you can find out about that and the final IDMN webinar series on LCCnetwork.org. So thanks for joining today, and thank you, Ashley, for managing our webinar.
Absolutely, you're welcome. Thank you, everybody. Have a great day.